Do the intro?
Yep. I probably need to do an intro. I didn't last time, though.
I liked it better until like 20 minutes in.
So you think my intro is pretty good?
Yeah, no, the delayed intro just seemed a little bit more enthusiastic.
Okay. Well, I'll try to be enthusiastic at the beginning of this one then. Hi, this is Tim.
And I'm Mary Bruce.
And today we are going to talk about art and engineering. And this actually comes from an interview that you did with Chris Granger that really caught my attention. You were talking about the connection between art and engineering, and mainly like Leonardo da Vinci is the one that comes to mind. And really, hold on, I have to do math to dismiss my alarm. Okay.
That's actually really smart. Holy crap, is it a surprise? Is this the prize calculation you have to do?
Yes.
Man. Incredible.
Where was I?
We were talking about, we had mentioned Da Vinci in that podcast.
Right. Yeah, so I was kind of jealous. You know, why did Chris Granger get to do an interview with you before I did?
He asked. Yep.
You know, and that's amazing. A lot of times that's all we need. Like for volunteers, that's all we need is to ask somebody. I mean, we are so freaking bad about getting off on red patrols. So, but in that interview, you talked about Leonardo da Vinci, among other people, that really, and I guess that's what I want to ask is, where does art end and engineering begin?
That's a really good way to question that, in a way that my brain just hit a wall. But
that's cool. Well, let's back up. Let's talk up because, maybe not everybody watched your interview with Chris Granger. Is really, you were talking about that Leonardo da Vinci, a large amount of really mechanical designs, and really he was sketching things out, just trying to figure things out, trying to share what he was thinking, trying to explain to others. Was he an artist or was he an engineer? Or yes.
Yes.
Yes, the answer.
Michelangelo, and M.C. Escher are probably the ones that make me think about engineering the most in science communication. The conversation with Chris Granger was based on STEM versus STEAM and those acronyms and how that relates to our ability to recruit to the manufacturing field. The A for me is the oddball out. That's the way that you can get a bigger group. Science, technology, engineering, and mathematics, still to me as an adult who is absolutely enthralled with all of that, it still sounds like a snooze fest. Or it also sounds like I'm going to have to burn a lot of mental calories with probably little reward, or it'll be like a group project or something. The art is the communicator to the folks of us that want to be involved but also not try so hard. The Michelangelos and the Da Vinci's, it's fascinating because they were polymaths. They were interested in it all. The physical aspects, the illustration, both of them were incredible draftsmen, which is, we don't have what we've built in our United States without someone being able to draw it out. And so the art aspect is really integral. Where it stops is really difficult, and that's actually why the A is such an issue to get involved, is because an engineer see a draftsman and they don't think you're not doing the math and computations, and the draftsman's like, but I'm doing a whole different thing that you need to know.
You're selling it. You're making it where you are the interpreter for all this crazy math stuff so the normal person can understand it.
Does a structural engineer actually want to work out the more elementary aspects of how things go together, or do they want to have it presented so that they can have the brain space to do the things that they need to do, like a manufacturing line, as far as thought processes are concerned? The art thing is incredibly important for nonverbal communication. Art is the first language. It's the language that we all communicate with. The other things that are involved in that acronym are more specific, and you have to have a lot of language, a lot of numbers, a lot of words, things that don't excite all of us.
Yeah.
I want to talk about hinges, man. Anyway. So the art, where it stops is, it doesn't. From my perspective, art does not stop in any of those fields. What stops is the other stuff. The math eventually stops. Art people have to do math all the time.
Mm-hmm.
Like we didn't get silver tone processes, any of the, I talk a lot about photography because that was what I studied darkroom photography for 4 years. So I talk a lot about that. But I found ways to do that where I don't have to use math either because shapes and colors are basically ratios.
Well, but aren't ratios math?
Yeah, absolutely. But to the person that like is has negative associations with math, we're gonna find another way to have those acronyms help us.
Mm-hmm.
Like if I add Dectol and another chemical to it, it's gonna change colors. If I'm looking at a purely yellow chemical, I know that I didn't add the other thing that I need in there. It needs to look a little bit more cloudy.
Mm-hmm.
Where do you think that art and any of the things that we study and talk about, where do you think those things end?
You know, and I have to say, you know, Mary and I, we have these conversations all the time. She definitely stretches my mind because we kind of do come from two different sides. And, you know, as a kid, I do remember sketching stuff. I remember having a sketchbook, and somewhere along the line, I lost that. But
and you mean not, you didn't lose the sketchbook, you lost the practice of sketching.
Yeah.
You stopped sketching.
Yeah, I did stop sketching. And I don't know why I stopped sketching, unless maybe it's just your brain can't handle but so much stuff. I don't really know.
I mean, you still sketch it out in your mind.
Yeah, I do sketch it out in my mind. And, you know, and I still enjoy, I actually do enjoy, you know, drawing something. It's not, maybe not as pretty as it used to be. But I think you're right. It's in the math part. I think that's where we lose a lot of people. I totally lost where I was going.
You're
with all
good.
this.
So the A in art is important because it helps the people that are not, we even in engineering, we have different certifications on purpose. PE is not going to do the same thing that any of the other folks are going to do, right? And
Right.
that takes a special kind of person that has a lifelong dedication to intense mathematic, material science, knowledge of degradation. Like, I mean, there's a bunch of stuff that person needs to know, but we don't need 7,000 of those in a, you know,
Yeah.
on the Eastern Seaboard or whatever. There's a whole bunch of people that do engineering fields that's not the requirement for them. So to make them go through that whole rigmarole to get back to where they would have been if they had never done it, it's basically just putting them through a bunch of emotional labor that never had to happen, and debt.
Well, and how many of them do we lose on the way?
Right. And so then they're so traumatized by the experience of trying to jump through hoops for someone else when that's not even the situation that they needed to be doing. You know, they needed to be a foreman. They needed to be a draftsman. They needed to be something else. There was another niche. There's enough niches in each area of those studies that they can still be involved and they can still identify as that without the social gatekeeping that is basically just a human construct that's made up, like of you're not good enough to be like me. And that's not fair because what you are is, you know, probably just a game that you've made up to yourself. So like, it doesn't even matter.
You know, and that's interesting because, you know, really, gosh, I remember all those math classes. And yeah, they were a total pain in the rear. And and rarely used them. I mean, I honestly, you know, didn't use them, and that may have been the final thing. You know, that, you know, looking back, it's like, okay, why did I decide that? Oh gosh, no, engineering's not for me. Because really, you know, I could do the math, but it just seemed never ending. It seemed like a lot of theoretical stuff, and that's why I kind of wonder if, you know, maybe that A might have even helped me. Is, you know, because really it was a lot of you know, a lot of widget designs, and like, what the heck is a widget?
Yeah.
You know, we probably could have put something around it, skinned it a little bit, and been like, okay, well, here we are going to make our favorite Klein wire strippers.
Third time's the charm. They're gonna call us, right?
Oh, there! I got to point it the right way if they're going
Put
to
the
call.
800 number like right down here.
Yeah,
Call us.
yeah, you know.
Fine.
But we could have been like, hey, you know, we're going to design a better set of wire strippers, because let me tell you, as we learned, all wire strippers are not the same. But we could have wrapped it around something like that, and then been like, okay, let's talk about ergonomics. And there, ergonomics is definitely art, because we can make a practical wire stripper, and it's insanely uncomfortable, and we've had lots of those.
Yes.
And, you know, that is an engineer's wire stripper.
Yeah.
But when you get starting to put ergonomics and maybe color and, you know, branding, you know, all those things are important to the design of a product. But
doesn't make it user friendly.
Yeah.
And one of the first classes that I took when I went to school was an interior design class, and that was it was a survey course. So there was hundreds of people in it.
Mm-hmm.
And one of the first things that we did is we all had to go get a wheelchair, we had to get a blindfold, and we had to get a couple of other things that made it so that we had situations in which we could not do the things that I'm used. Luckily, I'm used to walking everywhere I go.
Mm-hmm.
But riding around that campus in a wheelchair made it a lot more difficult. Being able to include things that help for ergonomics without reducing the amount of traffic flow that I was essentially learning about civil engineering in an interior design course was fascinating to me. And
that actually is fascinating because, yeah, that was not in any of my courses.
No, and so we took the next unit that we did on that was actually talking about go look at a can opener at Walmart, go look at it, and I'm saying brands here, but just don't crucify me for it, okay? Yeah. Go look at a can opener at Walmart and go look at a can opener at Target. And they said that these two companies have gone two different routes. One has gone for the economy of the situation, and the other one has intentionally chosen to sell things that are physically pleasing to the eye in addition to cost. And so it was fantastically different. The can opener from Target was beautiful. I mean, you're like, dang, this is cool. Like, this is a sculptural project and not just a functional piece, but I mean, it not only did it function well, it was also visually attractive, which makes it more fun to use, you know?
Well, and obviously, I think it makes it sell easier. And I think that, good grief, this is why I love having these conversations with you, is really, that is totally missing from engineering. And I do want to bring up a comment that somebody left, and here's the lack of the A in STEM, is I appreciate the care you take, but I promise no electrician, technician, maintenance man, or engineer will care about slight scratches. You could really speed up your builds by not worrying so much about little scratches and dings. Trust me, they're going to get messed up anyway. It's like, no. He needs to realize that our customer may not be the electrician, technician, or maintenance man.
No.
It might be like the end user who's paying a boatload of money for it and he wants it to look good. And I see so many engineered systems that look insanely ugly. And it's like, if you adjust, just like you did on the linear actuator trainer the other day, I had a nice clunky design. And I'm like, hey, Mary, come over here and just tell me how we can make this look better. And you're like, well, here, just put some angles here and do this, and it'll look so much better. You were right. It's like, holy crap. Now it now no longer looks like a functional system. It looks like a functional system that will sell now. So
a quote from that department was always, and I'll always get it wrong because to me it's very subjective, form before function, or form follows function, function follows form. And I think either way that you do it, basically it's important to involve both. The form and the function of it that's how we show we're passionate. That's how we show we care. Mm-hmm. So if we make something and it works, great. If we make something and it looks nice and it feels nice and it's more pleasing, then I actually take interest in it. For the people that literally can't learn unless they're interested in it, you're kind of giving them a dangerous situation to give them something that's uninteresting to look at.
Yeah. One of my customers, and obviously in the end, he did want it to work, but he always say, just remember, it doesn't have to work. It just has to look good. and really though, when you're in a project and you have someone who probably is not fully got their hand around how something's supposed to work, they just know they need it to work. If they walk in midstream through a system and it looks like crap, they're going to start getting frustrated pretty quick. They're like, we've invested this money and it really looks like we have a bucket of bolts that's not going to work. Whereas if it looks really good, even if it doesn't work, we're like, yeah, we're working on it. We're going to get there, and they're not going to question anything. They're going to look at it and be like, yeah, we're getting our money's worth. I'm excited. Yeah, let me know when you're ready for us to have a look at it.
It's a really topical discussion in the news right now, having devices that don't work and going on a hope and a prayer and having the design of it emulate function, like that it will function. We just need more money for research and a lot more people, and we need a better culture in our work environment so that people don't feel like they're being marginalized. It's important. So like if you can make a system that looks good, there's always a way to make it work. The art brain people are, I don't think there's any question about it that they're usually outcasts. You know, they think differently. It's obnoxious to kind of deal with them, you know, every once in a while, because they're not, you know, it seems like they're not considering all of the constraints, but they're considering all of that, and in addition to that, they just want to make sure that it's something that will not cause issue or panic. You know,
Right.
if I look at a control panel that's insane, it's not so far-fetched that I would consider my own death if I touch it, you know? Like, if I can see where things are going, then I'm a little bit more at ease on what I'm getting into. Just like if you buy a house and flip it, you know, like it's much easier to buy a house that looks good already and find out that, you know, it's got termite damage, you know, way under the ground, and you wouldn't have known. You buy a house that's a hot mess and it's actually good structurally. It's in the eye of the beholder, I guess.
Yeah.
But form and function are very important. Lost it.
I just totally think it's fascinating that one of your first courses really was almost more of a ergonomic design, mechanical design, than it was an art course itself.
I learned more in that one class in one semester than I learned the entire rest of the time I was in school. Now, did I choose courses that I intentionally would not learn it? Yeah, maybe. But the goal is that got my whole brain thinking about what we do and how we do it and why we do it. When we look at builder grade materials, or when we look at anything, we talked recently about old houses, that all this fancy trim work that we see in houses from the 1800s came from a catalog, just like the builder grade materials of today.
Yeah.
Why are they different? Doesn't cost a whole lot of money to make it like we used to. It just, the wood has literally changed.
Yeah, our perspective has changed. You
Yes.
know, what is pleasing or what is modern or whatever that word is I'm looking for. But it is interesting. I promise you, I never had an ergonomic course, a aesthetics course, or anything like that in engineering. And here you are, your freshman year, you have probably the most important course of engineering. No, I don't think we actually mentioned it. What type of degree do you have?
I have a studio art degree.
Yeah.
Yeah. So probably, if I would have stayed one semester, could have had like 4 or 5 degrees. But it was important for me to just get that 4-year stamp of whatever, because that's another manufacturing industry is college, right? We send people to college to create industry in our areas. The studio art degree allowed me to piddle with the science, math, technology, art, and engineering without anybody telling me that I sucked at it. So that was great for a self-esteem builder, right? So you end up doing this and you take the class, and sometimes your work is better than the other folks, and sometimes it's not. Sometimes you have the worst work, but the professor's the most complimentary of you because you went outside of the box. It basically was a degree based on play and cerebral thinking, and I didn't mean to do that. Everybody was disappointed that I did, but you know, I got the degree. That's what they said I had to do. So, but the art, had I known that I was actually good at these things and actually had an interest in it, I was intimidated by having to take math classes. I mean, I've been in remedial math my entire life because to me, there's no why to it. I'm not having to solve a problem to save my own life. Same thing with science. I'm not naturally good at it. We've all seen art where we said we could do that. You know what I mean? And that's appealing because they're in a museum. You know, you're like, well, if I can do that and they're in a museum, then, you know, I have value. Building up of that self-esteem is basically where the divide goes. So if we gatekeep our profession by saying your engineering experience is not as good as mine because I have these degrees and certificates and I can do this equation in my head, then the brain space that you took to get good at that is the brain space that you or I have used for something completely different. That they're not going to be able to think of. We all have the same size mind. Like, it's all made up of the same stuff. So, like, it's to say that one person's better than the other. It all serves a purpose. The art is the catch-all. We speak with another engineer on a regular that has a studio art degree.
Yeah, and probably one of my favorite people to work with. I'll be very practical. We're going to get it done. And also, I mean, does the little things that we know the operator's going to be happy. It has those smooth edges on it. Whereas, we work with a lot of engineers that definitely don't have the smooth edges on it.
Yeah,
it's really practical.
They're not thinking about it from a user's experience, the ergonomics of it. and that's incredible. To getting people to do a good job, you have to make them feel good about it. And so if the machine that you've made makes you feel not good, you're not going to get a good product. It doesn't matter if a robot's the end of the line. It doesn't matter, because the person that's operating the robot needs to want to show up.
Yeah. Well, and that probably was one of the early lessons I learned is, I could make a practical machine. And really soon, I mean, operators, they're going to tell you, like, hey, this stinks. I got to do this. And, why do I have to keep turning around and doing this? They're going to tell you really quick. And it's like, well, I don't know. I just figured I just needed buttons. I didn't realize that it mattered where I placed the buttons on a machine.
Yeah.
So really quickly, you do. It's like, okay, you start learning about, okay, how do we make this where, one, the operator's going to be safe and he's going to be happy running it. It's not going to be like, I have to turn around, 5 times a minute to operate this machine. No, let's just keep it where,
Yeah.
you kind of stand up and, not be hunched over and everything's smooth. But yeah, those are not things that are taught.
No, and it's not something that comes inherently to a lot of people. I've talked before about education gap. I haven't been in school in a long time, but I remember when I was a kid, we got lobed off from each other. It's been typically, I hate to take it to the gender situation, but we kind of need to a little bit. The homemaking aspects of the things that I was taught, that it seemed like my male peers were not being taught unless they just absolutely did not want to participate. I had a few boys in home ec with me, and that was great. But the things that we had to learn in that about making presentations, making meals attractive, color coding of those things so that your family will eat your food, those types of things that probably haven't been, I don't know. There are people that are genuinely interested in that. I'm not. I will eat Soylent Green if it's given to me. I do not care. Just please, if I could drink gasoline to make my body go, I would do it. I have not, and I will not do that. Just disclosure.
Okay,
But that stuff isn't quite as focused on in shop class.
What do we need? Do we need to have a conversation on gender?
We can. I love them.
Okay.
I love that.
Okay. Well, we probably need to get a little more work done.
Yeah. The art situation, I do feel like that's a great way to breach that, not just the gender gap, but the learning gap. So it's not that the minds that learn differently are less able, it's that they need a different path to get there.
Yeah.
And they're just as important.
Okay. Well, let's get a little bit of work done, and then we'll talk about the gender gap.
Gender gap.
Yeah. Thank you so much, Mary Bruce, as always, and till next time. Hi, this is Tim.
And this is Amber with TW Controls. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like these.
When you're ready for some intense PLC training, check out our PLC lab.
And if our videos have helped you out and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!